Previously, we looked at using our calculator to make a table of values and sketch the graph of an equation. So I give you three equations here in number one, and just to review it, I am going to look at part C with you, and then I'll have you finish the other ones before you go on to the next part of this video. So just to review, graphing, part C, y equals -3/4 x plus 6. Remember to graph this in your calculator, you press your table button, clear whatever equation is in there, and then I'm going to enter in -3/4 x plus 6. So if I want to put a fraction in, I could do the n over d button, and I could do -3 divided by 4. Now to get out of the fraction, I can use the arrow key to the right, and I want to do times x, and then plus 6. Press enter and it takes you to the table setup. If I started the table at say -3 like we usually do, the step of 1 means we're going to go up to -2, -1, 0, 1, 2, and so on. And then the auto means it's going to generate the table for you. So go ahead on OK, and there's my values. Now notice what happens here is I'm not getting nice answers. And if you go back and review previous lessons, that's because of the fraction in front of the x. So when you put a number like 3 in for x, or -3, so when you put that in, it gives us 33/4 as an answer. When you substitute that in, that gives you +9 over 4, which is not going to be a nice integer for an answer. But if I scroll through the table, notice that when I go to -4, it gives me a nice answer of 9. That's because when you substitute -4 in, the 4 and -4 reduce out, and it'll give you a nice answer there for that -3/4 x piece of the equation. So if I make a little table of values for x and y, I know that -4 gives me that answer of 9, and that'll fit on the grid. And then if I scroll to larger numbers of x, so scroll down in the table, 0 gives me a nice answer of 6. And we know that 4 will be the next nice answer when you substitute 4 in for x. Okay, it gives you +3. So those would all be values, or points, that we can plot on our axes. So you can do that, pause the video, and plot these three equations for A, B, and C. And I'll put the answers up. Okay, so here's a small table of values for each of the equations. And notice that I only included numbers for x that gave us nice integer values for y. In part B, y equals 1/2 x minus 1, notice only even numbers will give you nice answers for y, because the 1/2 would reduce with an even number to a nice integer. And here's what the three equations look like. I graphed this one off a little bit right here, but you get the idea. Okay, so that's graphing the equations using a calculator. At the bottom of the page, I discussed what we discussed in the previous video for slope. When we graph y equals 1/2 x minus 1, okay, notice that on that graph, we count up 1 and to the right 2 between any pair of points on the line. So that's looking at this equation here. Notice if I go up 1 to the right 2, up 1 to the right 2, that keeps us on the line. Any fraction equivalent to 1/2 will also keep you on the line. So if I go down 1, left 2, that's -1 divided by -2. Down 1, left 2, that'll keep you on the line. Also going up 2 to the right 4. So 2 divided by 4 would also keep you on the line. Okay, so one of the points there is to notice that that number in front of x, so in that equation, y equals 1/2 x minus 1, that 1/2 is telling you how to count the slope. Up 1 to the right 2, or it's telling you what the slope is. that minus 1, well, notice that when x is 0, half of 0 is 0, and then subtract 1 is negative 1. So notice what that gives you on the graph is the y-intercept. So that's the really important part of this video, is looking at that form that you're given. So on the second page, we have what we call slope-intercept form for a line. So we should notice that each of those equations on that first page is of the form y equals mx plus b. M is the slope or the rate of change, and 0b is the y-intercept or the starting value. This form, y equals mx plus b, is called the slope-intercept form for the equation of a line. Now they're not getting tricky there with you in calling that the slope-intercept form, because m is the slope, b is the y-intercept. That's why it's called the slope-intercept form. Okay, so in number 2, find the slope and the y-intercept of each equation. So we have y equals mx plus b. So the slope here is 2. The y-intercept, so the plus b value is plus 4. So the y-intercept, the coordinates will be at 0, 4. For the next one, y equals 1/2 x minus 1. The slope, so the coefficient of x is 1/2. And the y-intercept, we have y equals mx minus b. So instead of minus 1, we can think of that as plus a negative 1. So when you look at y equals mx plus b, now the b value is negative 1. So 0, negative 1 is the y-intercept. And then the third one, y equals mx plus b. So the slope is negative 3/4, and the y-intercept is at 0, 6. And notice that the y-intercept always, every single time, has 0 for the x value. So in number 3, it's a matter of graphing the equations and identify the slope and the y-intercept. So what we're transitioning into here is not using a table to plot lines. If we recognize y equals mx plus b form, then we can plot the point and then count the slope from that point. So if here the slope is negative 3 and the y-intercept is 0, 5, all that is asking us to do is we'll plot the point 0, 5, so we know where to start at. And then from that point, we'll count a slope of negative 3. Well, remember, a slope of negative 3 is the same as negative 3 divided by 1. So we count down 3 to the right 1. So from that starting point of 0, 5, we'll count down 3 and to the right 1. Down 3 to the right 1. And that'll keep us on that line. So I'll connect those with a ruler or straight edge. And that's graph A. Going on to graph B, y equals mx plus b. So here the slope is negative 1/4, which means we count down 1 and to the right 4. Remember that negative slope, always put, if you put the negative in the numerator with the 1 here, then you won't miss it. So just down 1 to the right 4. And the y-intercept at minus 2 tells you that we have 0, negative 2 is the y-intercept. So take a minute and finish B and C, and I'll put the answer key up here. Okay, so here are the slopes and y-intercepts and the graphs for each of those. In part C, Notice that we have y equals 1x minus 6. So if there's nothing written there, it's assumed it's a 1. So the slope is 1. As a fraction, that's 1 divided by 1. So for a slope of 1, you count up 1 into the right one. So that is how you transition out of making tables for these equations and into recognizing y equals mx plus b form, and then counting the slope from the starting value of the y-intercept.